Hello friends, you're welcome to our class. Today we are going to be looking at simple AC circuits. This video is going to concentrate on solving problems on simple AC circuits, because in our previous video we have introduced the topic simple AC circuit. We have carefully explained the concepts and derived some formulas that are going to help us to solve questions. So this particular video is just going to be solving questions. If you want to get the background of this topic simple AC circuit, I advise you go to my previous videos and then you will find the simple AC circuits or introduction to simple AC circuits, so that you will understand the concept before you can dive into solving questions. Because if you do not understand the concept, you might not be able to understand what we are going to do here. But before we proceed, please subscribe if you have not done that. If you have done that, like my video, share it so that other people can benefit, not just you. So it is good you help us promote this video so that you can see other videos. We'll have the strength to do more. If you do not subscribe and you do not like, we will be demoralized from doing that. It means you don't like the video. But please, if you are going to enjoy this, if you are going to learn from this, please try to subscribe and share to others. Okay, let us see how we can solve this question. It says an RLC series circuit. If you have watched my previous video, you will know that RLC stands for resistance, inductance, and capacitance. So it is a circuit that contains both a resistor, an inductor, and a capacitor series circuit. Okay, it consists of 100 ohms resistor. I always say that if you are to properly solve questions, calculation questions, it is good you itemize or list your parameters so that you'll be seeing them and it will give you an idea of the formula to use. R is 100 ohms. Okay, my board is small, so I'm going to manage it. L, which is an inductor, is represented with L, 0.05 Henry inductor, and a 25 microfarad capacitor. The capacitor is represented, capacitance is represented with C, that is 25 micro, this is microfarad, and micro is 10 raised to the power minus 6. So this 25 times 10 raised to the power minus 6 farad. Okay. A 220 volt 50 Hz means voltage is applied across the circuit. The voltage is 220 volts, while the frequency is 50 Hz. Calculate the impedance and the current. You will know from our previous video that in an RLC circuit, a circuit that contains resistance, inductance, and capacitance, impedance is the square root of XL minus XC squared plus R squared. I properly explained this formula and how it was gotten. So if you look at this quantities of parameters provided, it is only R that is here. We don't have XL and XC. Where XL and XC are the reactants, the inductive reactants and the capacitive reactants. This is an inductor. So we get the inductive reactants from an inductor, we get the capacitive reactants from a capacitor. So we're going to gradually get that. The inductive reactance is gotten by angular speed, that is omega L, which is 2 pi f L for an inductor. We know what a pi is, given as 3.14, and then f is the frequency and L is the inductance. So if we substitute here, our XL will be equal to 2 times 3.14, as the question gave us, times frequency 50 times inductance 0.05. Okay, let's punch our calculator. Let's quickly punch our calculator. 2 times 3.14 times 50 times 0.05, that will give us 15.7. So the inductive reactance is 15.7 ohms. When the inductance has been changed to a resistance, it is in ohms, no longer in Henry. So the same way, the capacitive reactance is inversely proportional to the frequency and capacitance. This one is going to be 1 over omega C, which is 1 over 2 pi fc. Okay, so the capacitive reactance is equal to 1 over 2 times pi, which is given in this question of 3.14, times the frequency, which is 250 Hz, times the capacitance, which is 25 times 10 raised to the power minus 6. So XC is equal to what? If we properly compute this, we'll get 127.4 ohms. Some of us do not know how to punch calculator. If you cannot punch this together, how do you punch it? You can say 1, punch divisions, and then open a bracket and type all this and close the bracket. It will give you the answer, this answer. If you don't want it that way, you can actually punch the denominator separately, write what you got, then you go back and punch 1 divided by that answer you got. It will give you 127.4. But I'm not teaching how to punch calculator. So this is a capacitive reactance, this is inductive reactance, and this is resistance. So with this, we can use this formula to solve. I'm going to clean the question because we don't have space in our board. We are asked to find impedance and current. Take note of that. Let us not forget the impedance and the current. So from here, the impedance, which is Z, is equal to, substituting into this formula, we have XL, we got it as 15.7 minus XC, we got it as 127.4 all squared, then plus R is 100, we have 100 squared. So if we simplify, the Z is equal to 12476.9 plus 100 squared is 10,000. So if you add 10,000 to this, Z will be equal to the square root of, add 10,000, we have 22476.9, and the square root of 22476.9 is equal to 149.9 ohms. So this is the impedance. This is the impedance. So from the impedance, we can now get the current. Remember, this is I, where we have to find the impedance, and then the II is to find the current. We have gotten the impedance. I can now clean this. The voltage is 220 volt. Remember. So from Ohm's law, we know that V is equal to IR. I have explained this in our previous video, but the resistance here is impedance. So V is equal to IZ, not IR here. So if we make I the subject of the formula, we divide by Z, we have V over Z. So the current is going to be equal to, the voltage is 220 volts, and the impedance is 149.9 ohms. So if we punch our calculator, we have 220 divided by 149.9, that's going to give us 1.468 ampere. Okay,